Hello, my name is Gerhard and I'm a data scientist at SAS and a passionate sailor at Lake Neusiedl. In my presentation today, I would like to combine my favorite topics, sailing and analyzing data, into one presentation and discuss with you on how we can analyze the water level data of Lake Neusiedl with statistical methods and run simulation scenarios. Lake Neusiedl lies in the eastern part of Austrian Burgenland. It is a very large lake which lies in a very flat area here in Burgenland, and it is a very shallow lake. Lake Neusiedl recently got a lot of press because of its historic low level of water. So you read news like there's a historic low level of water, there's a discussion whether there should be an artificial water supply for the lake, and you see this across different newspapers and magazines in Austria. You can also see from the picture here in the harbor that the difference between the water level and the dock is increasing, and many boats are even below the dock. How come? What is the reason for this low level? One of the main reasons is the nature of the lake itself. 80 to 90% of its water balance is fed by precipitation. So there is not a main river floating into the lake, but the lake depends on years with a reasonable amount of rain. And the first 5 months of year 2020 have been extremely dry. So you see here from the graph published by Hydrologie Burgenland on their website that you see there has not been a large amount of rain recently within the last 5 months, and this is quite below the long-term average or the last year's amount. There's also a publication from Karl Maracek from Hydrologie Burgenland that especially the precipitation in winter strongly contributes to the creation of water reserves, which definitely didn't happen to a certain extent this year. And we can also see already that the water level dropped below the long-term average for the month May. So what we see here, the effect here on the left, not enough rain, has a direct effect on the water level of the sea. So how is the author of this webinar involved? As already said, I'm a passionate sailor. I like to sail on the lake, I like to be on the lake, meet friends there, and I really hope that we get more rain and the water level rises again. What I'm going to show you in the next a couple of minutes are some ideas on how you can run simulation scenarios to see how the future, the next 4 months, could look like. I'm also analyzing hydrological data from Lake Neusiedl together with my students at Business School of Burgenland in my seminar when I teach them. So we run descriptive statistics there, we also do simple analytical models, we discuss how we can do data preparation over time, and we also find out how can we model the water household of the lake by rain, evaporation and other factors. Our typical analysis process when we analyze the data is as follows. We load the data from the website of Hydrologie Burgenland. This is a great website where I encourage you to visit it because you can download data for the last 30 days there. You find a lot of graphs and explanations and comparisons over time of the water level, the rain, and also the temperature. And they are also a very good role model how to publish data and how to make it available to the public. After we loaded this data into our analysis system SAS, we go and prepare our analysis tables. We join the data, we aggregate them from a 15-minute intervals to hourly intervals to daily intervals, and we prepare the data by creating derived variables and appending the data, the freshly loaded data, to the data we already loaded historically. After we have done so, we go and run certain analyses like correlation analysis, line charts, and many other types. So the question that might arise now, why should we worry? The current water level at the lake is maybe not too bad if we compare it with the long-term average. However, is this really the case? Let's have a look. In this graph, you see a histogram for the water level over the last 20 years. If we just take a look at this graph overall, we might say that the actual water level, which I indicated here as a reference line, is maybe not too bad. It does not lie in the middle or in the above section, but it lies somewhere in the lower quarter. The problem, however, is that we are looking here at the measurements of the entire year, and if we subgroup this now by month, we see that for the month May, we usually have higher water levels, because in winter a lot of water comes into the lake and the water level rises, and then over the months, June, July and August, the water level slowly goes down. So the point is that the actual water level is a problem, because in May usually the lake has more water. It would not be a problem if we had already August or so, but we can expect that the water level from now on will decline over the next weeks and months, which we can also see here in the long-term trend. In my box plot, we see that in March, April, we have usually the highest water level, and then starting in June, July, August, the water level goes down. So we can expect that over the next months, the water level will also go down, and this is something that I would like to simulate here. You can also see a similar picture on a graph published by Hydrologie Burgenland, where you see that the actual level of water, indicated here in red color, is quite below its long-term minimum, and you see in black the typical average and the seasonal cycle of water level in the lake. I have also loaded the yearly course of the water level into my analysis system, which I will use later on to run simulation scenarios. In this graph you see the yearly water level course over time, and you see the variation that we had very dry years and years with a lot of water. So let's take a look at the actual year. This is something we started here. However, the water didn't really rise in April and March, and starting with April and May, water level went down. We also had years with a lot of water, for example 2008, 2009. These were years when there was 2010, when we had a lot of water in the lake. And we also had years like, for example, 2003, 2004, 2005, where we didn't have a lot of water in the lake. What I'm going to show now in my analysis is what happens if we concatenate the data here by 1st of June with all the individual lines from the other years. So what happens if a year continues to be like 2003? What happens if our year continues to be like 2010? In order to see what scenarios, what is the variation which we might experience this summer in 2020. As a first very simple model, I'm going to show you how I concatenated the actual year with historic water levels starting from June from previous years. Frankly speaking, this is not a real statistical analytical model, it's more concatenating data from historic periods to the actual day to day. However, it will give us an insight what happens if year 2020 continues in the same way as we had the previous years. Let's have a look on the analysis how this looks like. Let's have a look what we see in this graph. I have again created a line chart where we see here in the left section the course of the water level in year 2020. And then I have shifted and concatenated all the other 20 years that I have available in my data in order to give you an indication of what the variation and the possible scenarios could look like for the next 4 months. What I also added here is, in addition to the water level above sea level, 115.5 meters and so on, I also added reference lines that relate to the depth of the lake close to the harbor exit in Weidnamsee, where I usually sail. This makes it easier to understand and to compare and to relate what does it mean if a certain level is reached, because this is something which we can relate if at a certain place it's just 1 meter deep or just 80 centimeters deep. This is what we see here. So you can, in order to relate this to a business understanding, if we have levels between 70 or 80 centimeters, means that the lake, when you exit the harbor, is not deeper as usually your office desk or your kitchen table is, because they are very often something like 70 or 80 centimeters, to give a relation of how this would look like. What I also indicated here, 2 reference lines on 1st of June and here on end of September, because this is usually the sailing season where we are interested to have enough water in the lake that we can sail. I have now linked this graph in order to be able to filter the water level from previous years. So you see, I have here available the water level from year 2000 until 2019, and the length of the bar indicate the average water level in the respective year between June and September. So when we see 2010 would be a year with a lot of water in these months, and when we click on that, we see that on our right graph we just get filtered this one year, and this means if the actual water level would continue like in 2010, our scenario would look like this. We will stay a little bit above 1 meter of water deepness, and the scenario would look like this. And you can now click on here different scenarios. For example, how would it look like if it were like in 2009? It would like this. These are quite nice scenarios. However, for example, let's take some more recent scenarios. Like in 2019, our last year, we see that over the year we had a very hot summer and the water level dropped substantially. And we only would end up, if this year continues like the last year, with a water level of a little bit above 80 centimeters. And also the year before, and also 2017 indicate years which are not a quite nice experience, where we didn't have enough water, where we wouldn't have enough water if it continued like this. Also, if we take a look on years where we had very hot summer, like 2003, for example, where we even would drop under 70 centimeters, which will be a problem for many boats exiting our harbor in Weidnamsee. This means what we see here is even if it is a very simple, just a concatenation model, it gives us some indication of what would happen starting from this year and continuing like other years that you can select here on the left. And I have also color coded this a little bit so that it makes it easier to distinguish the colors in the line, and we can find out if we have a year with a lot of rain, what happens if we have a year with not so much rain. This is something very easy where we can simulate different outcomes, and definitely we all hope that we won't end up something like the summer in 2003 or some other years. In the next step, I added a little bit more statistics and analytics. I built a simple predictive model and displayed the results interactively in SAS Visual Analytics. So the basic idea I followed here is that I trained a simple regression model on a monthly level using two parameters: the rain that came down on the lake during that month and the number of days above 25 degrees Celsius, where a lot of water evaporates. And having this model available, I run various scenarios for different input parameters. What happens if we have a hot summer with not a lot of rain, hot summer with a lot of rain, and so on. And I allow to display and to play interactively with the sliders to understand the results and the scenarios in a better way. We will have a look at that in a second. The simple regression model that I trained is, as you can see here, I use as a target variable in my regression model the water level change on a monthly basis. So what is the amount of water that was added or that was lost during a month? And I go and explain this by two parameters: the rain sum in millimeters and the number of days where the temperature was above 25 degrees. So, of course, you might want to build a more complicated and a better explanatory model. However, from a simple regression analysis and simulation model, I only use these two parameters. I restricted the analysis on the months June, July, August, and September because these are only the months that we want to analyze here. And another comment, I used the number of days with temperature above a certain degree level instead of average temperature, because this is easier to understand and to evaluate for us humans, because we too hard to say what is the average temperature on a particular day. It's easier for us to say it might be a day with more than 25 degrees or less. The model that I built is, as I said, a very simple model, and you see that the rain adds to the water level with a factor of almost 1. So the water that falls into the lake increases the water level. What we also see is that a day with more than 25 degrees Celsius costs the lake something like 3.3 millimeters of water level. So if we have a lot of hot days in a month, the water level will go down. This model is now available for interactive usage, and what you will see on the next slide is a method how we can interactively play with what-if scenarios. What is our assumption for July, August, and September in terms of rain, in terms of hot days, and what is the effect on the water level? The regression model that we just built based on the two parameters rain per month and number of days above 25 degrees per month has now been implemented with the simulation engine of SAS. The interface that you see here allows you to combine your individual scenario settings on what you think or what you would like to test. What is the rain amount per month, what is the number of days above a certain degree per month, and on the right hand side the outcome of the scenario based on the regression model is shown. So on the left section of the line chart we see historic data until 1st of June. And on the right hand side, between 1st of June and the last day in October, we see the results based on the regression model that we just built. So we see, based on a certain scenario, which I used, which I set based on the parameters that we had over the last years. So the rain amount, the average rain amount in June, July, August and September, and the average number of days above 25 degrees in June, July, August and September. These are the settings which result in the following scenario. If you now play around with the scenario and say, let's assume there would be a lot of rain in September, and if we increase the rain, we see that this has an immediate effect on the rain and on the water level here based in September. So this is the way how you can use this. At the moment, the scenarios is set like an average year from the past 20 years, which means that we would go down at the end of the summer to something like 115.14 meters above sea level, and then lose another 2 centimeters in September. Let's now play around with the scenarios and say, what happens if we have a very dry summer? Very dry summer means we assume that we have 25 hot days in July, we have 25 hot days in August, and you see, while I'm changing the scenario settings back and forth, we see that the line here on the right side also changes immediately based on our settings. So let's assume very hot days and not a lot of rain, so maybe only 21 or so millimeters of rain. We see, based on this scenario, we will have a very low water level at the end of August, only having 80 centimeters of water level in front of the harbor exit of Vietnam Sea, which means that this is quite an undesired scenario. And we can now also change settings like what happens if also September is quite hot, maybe with 15 days and also not a lot of rain. We see how deep we would get with this scenario. So these settings allows you to study certain scenarios. So what might be a worst case scenario? Very hot June with a lot of very warm days from now until the end of August. Not a lot of rain until the end of August, and maybe then have something like an average September. We see that this would bring us down to 70 centimeters, extremely low level of water. What would happen if we have, let's say, a summer only with half days of very hot temperatures? We see that even just reducing the number of hot days per month already increases the water level, because there is less evaporation because of the heat. And we learned from the regression model earlier on that we are losing 3 millimeters per day on a hot day. And if we also increase the rain to something like 6 centimeters per year, this would be a scenario where we say, okay, we are losing something, but it doesn't look too bad. It might be quite a summer where also at the end of the summer we still have some water to sail. So what I showed you here is a combination of the analytic model we built earlier on, a display showing the historic data, and in future the simulated data, and here simulation scenarios where you can play around and say what happens in months with a lot of rain and very high temperatures. How does this affect the output? And this is a very good way how you can use analytic software in order to run and review your scenarios. Let's finally have a look on some considerations from a business point of view that I have used and that I have applied here in this analysis. As already mentioned, I have used by purpose the feature days larger than 25 degrees Celsius instead of average temperature because this is easier to interpret and easier to specify in simulations. I also added reference lines with the relevant dimensions to our plots. The measurement of the water level above sea level is technically accurate. However, in order to understand and to relate better, it makes sense to add reference lines. How deep is the water at a certain place, what you can relate to, what you can understand, and what has a meaning for you. I also gave the chance to select the year based on a bar chart where I display the water level from the particular year instead of just naming the year label. This is easier to understand and say, okay, this was a year with a high level in summer, this was a year with low level in summer, which is easier to understand and to better relate to. And finally, I also added in the sliders in the simulation analysis, I added the average over the last 20 years of what is the average rain per month, what is the average number of days above a certain degree level per month into the label, so it's easy for us to understand and say what I'm specifying here, is this a year with a value above average or below average. And this all makes sense to understand your data science analysis better and to interpret them in a better way and explain them to the business user. Finally, I wanted to show you that it is a very interesting topic for me because I'm a passionate sailor, but from a data science point of view, I've shown that even a simple model, just a concatenation model, can also provide relevant insight into future scenarios. We've also run what if analysis. They are very important to understand better future scenarios and to see what might be the outcome for the future. In our second example, we've applied analytics, a simple statistical regression model, but that captured and quantified the relationship of possible outcomes and displayed it in our analysis. So I hope you enjoyed what you have seen here from a data science, but also from a business point of view, the water level at Lake Neusiedl. If you're interested in more, follow me on my data science webinar at the SAS YouTube channel. And I hope we have a very good summer in terms of water level and we all can do a lot of sailing and enjoy the summer as we are used to. Goodbye and thank you very much.